Hello, everyone. I am back here at NYU Future Labs at the AI Nexus Accelerator, speaking with Mika Pera and Hamit Zaheri from Cambrian Intelligence. All right, guys, say hi.
Yeah, hi. Great to be here.
Hi, everyone.
So tell us about Cambrian Intelligence. What are you guys up to?
Yeah, so Cambrian Intelligence, the word Cambrian comes from a Cambrian explosion that happened some 60 million years ago. So we are developing robot OS made of AI modules. And that can be used to do various tasks and to solve, to enable robotics in every industry possible. Okay,
and with regards to the analogy to the Cambrian explosion, what is what's being exploded? Like, what are we seeing proliferate here? Is it the intelligence itself? Is it robotics? Is it?
Yeah, so we believe that sticking these narrow AI applications into our modules, we can achieve much, much more, and we can more rapidly develop different applications for robotics. So basically, what we are doing is making robots more intelligent.
And so maybe tell us a little bit about your personal backgrounds. How did you get to where you are? And
yeah, sure. So I have a background in aerospace and from Stuttgart in embedded systems and robotics. And then I moved to London. Then there I met Mika. Mika has a background in cognitive science and deep learning. And there we figured that we both share passion for robotics and for artificial intelligence, and we decided to start this company together.
Oh, nice. And how long have you been doing it?
A little bit over a year.
Okay. So you've been at it for around a year. What have you? Where are you at as a company?
Yeah. So right now we are working for pilot for a large auto manufacturer, and like to implement the first application out of our operating system on industrial robots. So we are heads down on developing that, and we plan to release the platform more broader late this year.
What specific problem are you going after that an automaker would have?
So right now, robots are programmed point by point to accomplish different tasks. The robot is blind. You put some specific parts into some specific locations with the accuracy of sub-millimeter, and the robot is programmed to just go there and pick the part and then place it some place that's already defined for the robot. But the robot has no knowledge about the environment or the task that it's trying to accomplish. What we're doing, we're trying to make that robot more intelligent, so the robot can have an understanding of the environment and can accomplish the task by self-learning. Then there won't be any need for programming the robot. We're basically changing the abstraction level of robot programming from low-level programming of the robot with the code to high-level, just specifying the task and the specifics, the location and the initial location, the target location, and the robot can figure out on its own how to accomplish the task.
So I've seen a bunch of videos of, from a variety of different sources, actually, with showing robots trying to do these pick and place types of operations. And there are a number of challenges, including, you mentioned the millimeter resolution with which you need to program the robot. What are some of the other challenges that you see folks having with the traditional approach to programming these robots?
Usually programming this robot is really time consuming, and it's not just the programming itself, but the robot changes the behavior with environmental factors, like even lighting conditions or temperature of the environment and so on can affect how the robot behaves. So every time these conditions are changing, they need to reprogram the robot. So our approach is to add that level of intelligence to the robot, that the robot can adapt to the new changes of the environment. And it basically can learn how to optimize for different tasks. And current challenges, it includes localizing the part with that accuracy that we mentioned, extracting the pose of the part, grasping the part from the right location, and with the right timing and so on. And these are the challenges we want to remove from the programming and let the robot to learn and so on.
Why the auto industry?
So auto industry, currently 2.3 million industrial robots out there operating as we speak, and 40% of those are in car industry, automotive industry, and kind of out of car industry robots, 70% operate in the body shop, which is where they make the chassis of the car.
So these are the pictures and videos you see with the car kind of going down the line, starting from the frame and then putting and those are massive robots that are involved.
Yeah, and they require like massive halls to operate, and it's a big task to configure. Like when you can imagine when a new car model comes in with all the different variants and how many parts the car is made of. So you can imagine the task of programming all these individual robotic cells down at the production line. So it's a massive task.
Do you have a sense for how long that usually takes for when a new, once I've completed design on a new car to complete the programming of the line to get it to market?
Yeah, so typically they practice the production, like they have 100 cars, 200 cars, and so on. And often, even with the production run practice, like you typically change the part in dimension or form to fit in better. But it's like you are talking in days of like very, very hard ramp up production. So.
I've also seen where, there are companies that are trying to solve this robot programming problem by, as opposed to, the traditional programming approach, basically have the robot shadow a human, or you kind of move the robot the way you want to move the robot to, you manually manipulate the robot in order to teach it. It doesn't sound like that's what you guys are doing.
That's part of our platform.
Oh, is it?
Yes.
Okay, so tell us more about, dig into the platform a little bit and how a company would use it.
So the basic idea of the platform is to enable people to have natural interaction with the robot. If there are tasks that the robot can self-learn, the robot can do it using our platform. If there's a necessity for the human to have a simple interaction with the robot to show some specific tasks,
okay,
still possible using our platform. Basically, we are trying to remove the need for the human to have expertise in the robotics in order to interact with the robots. We want normal human without that kind of expertise to be able to interact with the robot and be able to teach it simple tasks, or even more complicated in the future, hopefully.
So kind of like we see that all like teaching by demonstration, or even like teaching by scripting, or like even voice commands, like we see this like blend in our platform at some point in the future. So you can have any robotic arm on your table, and you can ask it to grab your coffee cup, and then it's able to do that. So that's where we are aiming at.
And now today the robots aren't even typically, or to what degree do the robots typically already have visual sensors? Or is that something that's has to be outfitted in order for a company to use your approach?
So we kind of, for industrial robots in the car industry, we're going to retrofit industrial robots with a specific set of sensors so it can sense around its environment. So.
Okay.
But we're not targeting to manufacture any specific sensor. We're trying to use off-the-shelf sensors and not really expensive ones.
Okay. And what kinds of sensors? Primarily visual, or are there other types of sensors that go into...
We started by visual sensors, but they're going to be sensor fusion using different inputs to enhance the performance.
Okay. I had a conversation with someone actually from one of the large auto manufacturers where they mentioned that one of the challenges that they were having in this space was that the robotics manufacturers are increasingly trying to, they see they see the data that the robots are producing in terms of the sensors that they already put on the data and their operating data as kind of proprietary, and they're trying to sell that now to the automakers. And are you finding it? Have you come across anything like that where the manufacturers are having issues automating because the robotics suppliers are making it more difficult for them?
Yeah, of course. Like many, especially big manufacturers, like they are very sensitive about the data, like what they have inside inside these factories. So they don't obviously want it to go away anywhere. So.
What when you're working with a client like this large auto manufacturer, what challenges do you run into as they seek to use your product?
So obviously, like for a quite small company like us, startup phase, and then scaling up to multiple factories around the world. So that's something like where you need to ramp up your operation force and so on and so. But we are not we are iterating there. So,
but in order to gain the trust of those big manufacturers, they definitely need a certain level of safety and precision. That should be proven over time, and they need to trust the product and make sure that it works before they can deploy on the manufacturing line.
So what's their experience with the product when they, you guys come in and get them set up with, I imagine, a small use case to start to build that trust? What does it look like from their perspective?
Yeah, so at the moment we are still, our product is not yet in operation.
Okay.
Yeah, so it's going there. So
what do you envision the user experience to be when you get a new customer on board?
Yeah, so the user experience will be very simple. So for them, instead of now programming the robot, they can just upload the CAD model of that specific part they wanna be equipped, and then they specify the end location where it needs to go, and so it's that simple.
And you mentioned so you, as opposed to having to explicitly tell the robot, give it coordinates of a pick location, you're giving them what instead? Or are you giving them coordinates but just not the dimensions of the item? Or
yeah. So the problem we are solving is not so typically that's where the part needs to go. For example, most of the operations are welding these parts or gluing these parts together.
Right.
So the end point is typically could be it's predetermined, but where do you grasp that part? If they need to custom manufacture jigs, so where they hold a stack of parts very, very accurately. And with every new part, if you have new model or something, you need to custom manufacture a new jig, and this is obviously a big cost. So we can just stack parts arbitrarily. And
but still, if the gripping location is specified, still the robot can figure out from exactly that location, but the parts doesn't have to be in that exact orientation for the robot in order to find. Even if they have some randomness in their orientation, the robot can still extract the pose of the object and recognize that part and the gripping location and grasp from there.
So there are two problems in there. One is kind of the bucket of parts problem, right? So how do I know what the orientation is? But then there's also, are you also enabling them to use general grippers as opposed to custom-made grippers for a given part? Or
for the specific task of manufacturing, they usually have their own specified tools or grippers that the system needs to be integrated with that. But in the future, a robot can learn to use different kind of tools.
So maybe let's dive into the technology a little bit. What machine learning and AI techniques are you using to make all this work?
Sure. So in the robotic industry at the moment, you don't have a kind of a common operating system that the robot can use. Every manufacturer, they make their own custom programs. Mm-hmm. It's really low-level programming. We're trying to make it a bit more general, something that imagine the operating system that has a low-level interface that can interface different kind of robots, and then there are high-level modules like recognizing the parts, grasping the parts, or collision avoidance, or any intelligence that you need in the robot behavior that are abstracted from the low-level communication, and they can grow and get better over time. And this makes our own our operating system.
Mm-hmm. And so, how would you characterize where you are with the product so far?
So far we've integrated with 3 different robot manufacturers. I can name it. It's KUKA, Universal Robots, and Stabli. And we're implementing some basic AI modules, but later we're going to open up this platform for people to add more skills to the robot and expand the platform over time.
So what are some examples of the AI modules that you've implemented?
So right now we are working on the very accurate localization. So that's the key value adding module in our product at the moment. And then we've added recognition and then simple robot controllers.
So what goes into localization? What are the challenges there, and how are you attacking those?
Yeah, so basic is kind of like where the uncertainty comes from is like what you can receive the resolution from your sensors, and then kind of how you can fit that into your model and kind of get accurate enough prediction over time and like over multiple samples, like, and what you do. But like going back to the modules, like you can think different kind of modules, like you can think of like safety modules where you can detect people if people somehow enter this cell where the robot is operating. So you can have these sorts of, you can have force feedback where you can recognize different forces when you're installing some components and so on. So.
And so are you building everything from the ground up from scratch, or are you using various open source libraries for the analytics parts?
It's a combination of both. We need some certain tools. We cannot develop everything from scratch, but there's a certain level of modification that we need to make to the existing tools to make them usable for that precision required for manufacturing, and that's the work that we need to accomplish.
Anything that we might know in terms of tools? Are you running on top of TensorFlow?
Yeah. On the deep learning side, we use TensorFlow, so that's great. We also use on the robotics side kind of like low-level commands. We use ROS, so on that side. So.
It's so in the robotic research, there's this platform called ROS, a robot operating system, and it has a kind of distributed architecture. The nodes can run in parallel, and they're communicating to the master node and so on. We're using the idea, the whole platform, like what has been developed for research, is not suitable for manufacturing in terms of safety and so on. But the idea is great, so we're trying to adapt those ideas, but implement our own version that makes it suitable for the precision required in manufacturing. Okay.
Oh, great. Anything else you'd like to share about what you guys are up to?
We'll share like in the bit later this year. Just follow us on Twitter and check out website, and you'll hear more about us.
Okay, awesome. How can folks? What is your Twitter, and where can folks find you online?
Yeah, it's called Kane, so search C41NT.
C41NT.
Yeah.
Okay, and that's the Twitter, or is that the
Twitter
website?
Handle, yeah, and the website is
caint.io.
Okay.
Caint.io.
Okay, got it. Awesome. Well, thanks so much for being on the show. It was great to hear about what you guys are up to.
Thanks for having me.
Yeah, thanks for having us.